Okay, chemistry 1010, sheet 2, 2024. Specialized cells in the stomach release hydrochloric acid to aid digestion. So these cells, we call them parietal cells in the stomach. If they release too much, the excess can be neutralized with an antacid. A common antacid contains magnesium hydroxide, which reacts with the acid to form water and magnesium chloride solution. As a government chemist testing conventional antacids, you use zero point 0.1 molar hydrochloric acid to simulate the acid concentration in the stomach. How many liters of stomach acid reacts with a tablet containing zero point 0.1 grams of magnesium hydroxide? Now you know that here you are reacting hydrochloric acid with magnesium hydroxide. So this is going to form, we've already been told the product is going to be magnesium chloride and water. So magnesium chloride is going to be so, and we have got water. So we need to make sure that our reaction is a balanced reaction, otherwise we'll not get it right. We have got two chlorines on the product, so I'm going to put a 2 here. And then we have got two oxygens here, so I'm going to put a 2 here also. So it's now balanced. From what we've been told, we have got 0.10 molar of HCl. How many liters of stomach acid? So we want the liters. So what does that mean? We want the volume of the acid. And we've been told it's going to be able to react with 0 0.1 or neutralize 0 0.1 grams of the magnesium hydroxide. So we basically compare the moles. Let's start with the number of moles of magnesium hydroxide. The first thing is we need to be able to find the molar mass for magnesium hydroxide. Let me just see what that is going to be on the periodic table. Alright, so if we get to sum up the molar mass of magnesium hydroxide, we're going to get 58.33, because magnesium is 24.31, oxygen is 16, hydrogen is 1. Let me just do that so that we just get to follow it properly. I'm going to use rounded off values. We have got two hydrogens and each is 1. We have got two oxygens and each is 16, the molar mass. We have got only one magnesium and it is a 24. 2 by 16, that is a 32, 32 plus 24 plus 2, that is a 58. So now find the number of moles. Starting with the number of moles of hydrochloric acid, number of moles of HCl, we know that now for HCl we've been given concentration and we want volume. So number of moles is given as concentration times volume. And the concentration is 0 0.1. Remember, molar is mole per liter. And then you are multiplying by the volume. This volume, we are assuming that it should be the volume in liters. Okay, so I'm just going to say V in liters. So this liter and this liter will cancel. So the answer is going to be 0 0.1 times V. So that will be 0 0.1 V mole. And then the number of moles of magnesium hydroxide, for this one is going to be mass over molar mass, and the mass is 0 0.1. The molar mass is a 58. So 0 0.1 divided by 58. That is going to give us a 0.001724 moles. From the balance reaction, the number of moles of HCl divided by the coefficient, which is 2, should be equal to the number of moles of magnesium hydroxide divided by the coefficient, which is a 1. Now, number of moles of HCl, you can see that was 0.1 V divided by 2. It should be equal to number of moles of magnesium hydroxide, 0.01724. So if I want to remain with V, I'll simply multiply the 2 in the denominator with the 0.0124 and then divide the answer by 0.1. So therefore, V is going to be 2 multiplied by 0.00. I left 1 0 here. 0.01724 and then divided by 0.1. So volume is going to be 0.03448. This is in liters. If it is in mils, it's going to be like a 34.48 mils or milliliters. Good. Okay, next one here. How many grams of sodium chloride are contained in 0.25 liters of a 5.3 mole per liter solution? You want how many grams? First thing first, let's find the molar mass for sodium chloride. Chlorine is like a 35.5, sodium a 23, that is going to be a 58.5. So first thing first, we've been given volume and concentration. We can find the number of moles. Number of moles is mass over molar mass. The mass, okay, this formula will not be able to work for this here for the first part. So we'll say concentration times volume. And concentration is 5.30 moles per liter. The volume is 0.250 liters. So the liter and the liter cancels. 5.3 multiplied by 0.25, that is going to be a 1.325 moles. Remember, I want to find out the number of grams. Mass now is number of moles times molar mass. The number of moles is 1.325. Molar mass is 58.5. So let me punch that again. 1.325 multiplied by 58.5. That is going to give us 77.5 grams. So that is it. For each of the following, balance the equation, identify the reactant oxidized and the reactant reduced. Okay, this one was... what number are we going to put in front of the HCl? What do you think? A 2. Because on the product we have got 2 hydrogen, so that 2 hydrogen. So when we put a 2 in front of HCl, we've made the chlorines to be also 2. But on the product, the chlorines are already 2. So I'll simply put a 1 here. I'll put a 1 here. I'll put a 1 here. Because zinc is 1, zinc is 1 there. HCl is H2 is 2, H2 is H is also to this side. CO is 2, CO is 2. How about copper chloride with aluminum to produce copper and aluminum chloride? What number are we going to put in front of copper chloride? Okay, so yes, you look at the chlorine. Here it's as a 2, here it has got a 3. So we'll swap these two numbers. We are going to put a 3 here and a 2 here. So if we do this, we've made the aluminiums to be 2, so we'll put a 2 here. Coppers became 3, so we'll put a 3 there. And then sodium reacts with chlorine to produce sodium chloride. How about this one? Okay, so first thing first is we look at the chlorine. We have got 2, there is 1, so put a 2 here. That makes the sodium chloride 2, so the sodium is also 2, and then we put a 2 there. Okay, all right. Does a reaction occur when each of these pairs of solutions is mixed? If so, write balance molecular, total ionic, and net ionic, and identify the spectator ions. For the previous question, I've just realized it's not done. So it is also saying identify the reactant oxidized and the one reduced. So if you see hydrochloric acid, it became hydrogen just, or zinc chloride whatsoever. So what you're supposed to do for this one, let me just use one example. Let me use the same HCl reacting with zinc to produce hydrogen and zinc chloride. Hydrogen, the oxidation number is a positive 1, chlorine is a negative 1, zinc is just alone, so it's a 0. This side hydrogen alone is a 0. Here is zinc. Chlorine we know is a negative 1. So this will mean that zinc will be positive 2 because 2 times negative 1 is negative 2. Should balance with the oxidation number for zinc. Hydrogen, you can see it's moving from 1 to 0. Chlorine hasn't changed. Zinc is moving from 0 to 2. When something is reducing oxidation number, that is reduction. The compound is increasing oxidation number, that is oxidation. So by definition, a compound that is oxidized is a compound that, let's first define what is an oxidation. What is oxidation? Oxidation can be gain of oxygen, loss of hydrogen, or loss of electron. Anything that undergoes those, it has been oxidized. So this compound zinc has been oxidized. Hydrochloric acid has been reduced, but is different from the reducing agent and the oxidizing agent if that's for them. Reducing agent is what undergoes oxidation. So this one is a reducing agent because it is undergoing oxidation, but it has been oxidized. HCl is the oxidizing agent because it has undergone reduction. That's how you are going to also answer the other ones. Does a reaction occur when each of the following is mixed? If so, write balance molecular, total ionic, and net ionic equations. Okay. So let's pick one here. Which one should we be able to answer? Okay. Ammonium perchlorate, or is that supposed to be plus sodium bromide? So first thing, okay. So first thing first, we need to know what a perchlorate. Do you know the formula for perchlorate? Mm-hmm. Okay, ClO4, yes. So this is potassium perchlorate. I mean ammonium. Ammonium itself is like this. Perchlorate is like this. So when these are connected to form the ammonium perchlorate, we are going to have this. And this is reacting with sodium bromide. Okay, like that. So already from what I wrote, the radicals, you can see that one is positive, the other one is negative. So the one which is positive will react with what is negative on the other one. So ammonium is positive, it will react with the bromine which is negative. So that will now give us ammonium bromide, and this is going to be able to the other product. You have got the perchlorate will react with the sodium, forming sodium perchlorate. So this is going to be the molecular formula. Is it balanced? It's supposed to be balanced, just like this. And then we write now the total ionic equation. So all these are going to be in aqueous, so meaning that they can all break into their ions. Apart from, is there anything that is not supposed to be in aqueous here? In which state is it? Okay. So if it is a gas where ammonium and bromine, then that means that, so if this is gas, then ammonium will break it into ion, perchlorate, break it into ion, sodium bromide, that is also ionic. Anything that is not aqueous, we can't break it into ions. Actually, when you are breaking into ions, you only use those which are aqueous. You don't use the solids and liquids. Aqueous and gases are supposed to be written. So one of sodium bromide or sodium perchlorate, one of them should be a gas or a liquid. Let me just find out which one is which. Okay, so sodium bromide is not in aqueous. Sodium bromide is supposed to be a solid. So this one will not be able to break. The rest of these will be able to break. So remember always gases and aqueous solutions, they are the ones which will be able to decompose into their respective ions. So this is cancelling with this one and this one. Then we remain with sodium bromide, which is a solid giving us bromine minus with the sodium plus. This one here is the net ionic. This one here is a total ionic. And identify the species, the spectator ions. Which ones are spectator ions here? Yeah, simply those things which are cancelling out. That is how you are going to also do the same with the first one. Potassium fluoride, that is going to be it, plus strontium nitrate. What is it? What's the state symbol for strontium? Strontium nitrate. What is the state symbol for strontium? So strontium, I wanted just strontium, not strontium nitrate. So strontium is Sr2 positive. And then nitrate itself. What is the symbol for a nitrate? Hmm. You know the symbol? So nitrate is like that. So when you react these, then you are going to have SrNO3 with a 2 down there. So these are the two that you're going to be able to react. So you remember that potassium is positive, fluorine is negative. The strontium is positive, this other guy is negative. So the product that you form, you expect to have potassium nitrate, and then strontium fluoride. Remember, strontium has got a 2, so that 2 will go on fluorine. And then we'll be able to break this into our ionic equation. So basically, that is what you're supposed to do. Strontium nitrate should be a solid. So when you're breaking this into the ionic equation, this one will not be broken. Use the oxidation number method to balance the following equation: aluminium plus sulfuric acid producing aluminium sulfate plus hydrogen gas. What is the oxidation number of aluminium here? 0. Oxygen, we know this is a negative. 2. Hydrogen is a positive. 1. Sulfur, this is going to be a positive what? Positive 6. Because 4 times negative 2 is negative 8. Take it the other side, positive 8, yes. Hydrogen here is 0. Mhm. So you put on each individual element. Okay, so oxygen here, it will still be negative 2. Aluminium will still be positive 3. And then the sulfate, 4 times 3 is a 12. 12 times negative 2, negative 24. Okay, so simply, is there anything that is changing here? The sulfate in, okay, let me just do that. 2 times positive 3 for, that is for aluminium, and then plus we have got a 3 for sulfur, let me put X, and then 12 for oxygen, and each is negative 2, and this should be equal to negative 2, which, 0, which is a sum charge of aluminium sulfate. 12 times negative 2, negative 24. If it goes the other side, becomes positive 24. 2 times 3 is a 6. If it goes the other side, it will become negative. So this is going to be 18. 18 divided by 3 is a positive 6, so nothing changes here. So what has changed? Aluminium moved all the way from 0 to positive 3, while else hydrogen moved all the way from 1 to 0. So what is happening? 0 to 3, there are 3 electrons gained. 1 to 0, 1 electron lost. So simply swap these numbers, multiply this equation by 1, multiply this equation by 3. But as you are doing that, okay, let's get to multiply. So we're going to have 3 on the aluminium plus sulfuric acid, and that is going to go into aluminium sulfate plus 3 on the hydrogen. But already when we are putting this, oh sorry, this 3 was supposed to come here. This was supposed to be a 1. We're not supposed to put anything there because we're multiplying this one by 1. After you do this, you're now supposed to balance this by inspection.